An Introduction to IFC and COBie. Hello thinkBIM, my name is Emma Hooper and I'm a Digital Information Specialist at Bryan Digital. I love information and I'm fascinated by the mechanics of it and how it all joins together to make patterns. On construction projects I'm an information manager, but I do a lot of other things as well, including leading the IFC and COBie workstream at the BIM Interoperability Experts Group on behalf of the Centre of Digital Built Britain. On projects, we all need information to enable us to do something else, a purpose, whether that's to perform a task, answer a question, or make a decision. The information flows from provider to receiver, and I'm not just talking about the receiver being a client, it can be anyone who asks for information. But how does the receiver make sure that the information which is delivered enables them to carry out their purposes in the best possible way? Before you ask someone to provide you with information, you have to flip the thinking round so that you think about the purpose first and the information needed to carry this out. Then when you ask someone to provide this information, you're in a position to say exactly what it is that you need. So you're actually specifying the information you require. This is what information requirements are. Bring these together and it completes an information exchange. So each information exchange goes through this process of specify, deliver and check. And this is what the information management process governs across all information exchanges during the life of a facility. As an information manager, my job is to come up with the workflows to make this happen. We've just looked at one exchange, however projects are made up of huge numbers of information exchanges, which generally move about in an ecosystem of chaos. Two factors behind this, and the first is the people-to-people exchange of information, or as I like to call it, the interoperability of people. Outdated procurement models and passing on risk has just increased the sheer amount of organisations involved on projects, created barriers and formed convoluted lines of communication. It fights against the information management process, which wants to treat information as being equal. It stops the client being part of the team with respect to information and forces projects into producing ambiguous information to cover backs. Clients don't want to define it so they can wriggle out. Contractors don't want to define it so they can wriggle out. And we just pass this on down the chain as risk. This is why looking at procurement is absolutely fundamental and the most important change we need, but also the most challenging as it disrupts all that we know. And we won't get true collaboration without a massive change. However, it's the second factor I want to focus on. Let's look at the exchange between provider and receiver in more detail. The majority of the time we use technology systems to help us carry out purposes, so the information provided needs to be imported into them, whether that's to reference in design models, for costing, or to import into a CAPM system. And also the information delivered to us will most likely have been generated using technology as well. But this is where the problems occur. In this case, even at one simple exchange, we can have problems getting the right data out of one system and then into another. There are no simple buttons we press to do this, and days can be wasted on projects trying to do the simplest of tasks. So where do we start with solving this? Most will think we need to fix the software. And yes, there is some fixing which is needed, but that's not going to solve the entire problem. And I'm now going to explain why. We'll start with information once again. Over the years, every specialism or even sometimes company has become an information silo. They all have their own particular language, classifications and conventions. This is developed ad hoc without consideration of the other silos and the overall bigger picture. And to join it up, that's where people come in with our ability to read between the lines, to interpret and assume. But this introduces a whole chunk of risk. And you could kind of get away with this more when projects were simpler. So to help reduce this and make our projects more efficient, as an industry we've moved towards technology to help us. This was the idea behind CAD and later the modelling side of BIM. But in simple terms, computers don't like unstructured, random and varied information across so many different scenarios. For me, the whole premise of BIM is about making as much of our information as structured as possible in a consistent way so that technology can understand it. One place we need to start is understanding the difference between structured and unstructured information. There is an overlap between the two, but in general, structured information is information data which is machine readable and can be queried, so asked a question of. For example, databases, models and spreadsheets. Unstructured information cannot be queried and needs a deeper understanding and interpretation, typically from a person to make sense of it. For example, drawings, reports, images and sound recordings. However, moving towards using more structured information is easier said than done. Because it's about converting the chaos into order. To do this, we need to remove the silos, rationalise it and bring the information together to see what we have. Then define what it is in accordance with logical rules, such as what the function of something is, rather than the varied nature of the English language, software, or bad habits which have evolved over time. And if that wasn't enough, we also need to join the information up. This is where we'll gain the real benefits because it's the connections which gives us insight and greater knowledge, and this will be key to everything we do in the future. So we need to go from this to this. To manage the information across the exchanges, we need to be far more consistent in specifying, delivering and checking it. Therefore, what we need is an information layer across the industry where unstructured and structured information can live together and gives us the rules for specifying, delivering and checking it. That doesn't matter if it's on capital works projects or for an annual lift inspection. But there's a barrier, us and the way we think. As humans, we relate to things far better if we can see them, if it's tangible. Which is why when it comes to information, we think of the software first, which we can see above the information itself. But information is its own thing and doesn't rely on software applications to define it. They just help to process it. As a result, what we tend to see are requirements and strategies built around the software, where EIRs are based around proprietary software, not universal requirements, so unless you use that particular software, you can't even bid for the job. Software should serve the information, not dominate it. These software applications have their own languages and rules which are made up ad hoc and sometimes not fit for purpose. They themselves are mini information silos, bring several together like on a project and they struggle to share the information between them. And this is why we have such problems with interoperability. Everything is used in its own information layer rather than just a common one. So the sticky plaster approach. We focus on more peer-to-peer solutions, where each exchange is a tailored solution between every permutation of software. Even then, the data will end up in different places. Managing all these permutations isn't sustainable, and we're not looking at the bigger picture. APIs and add-ins do not solve this. They only initiate the exchange without files. You still need a base standard to exchange data in a consistent way. Even if you have platforms that claim to open every file format under the sun, how do they know where to find specific data and what the relationships are to start to make sense of it? As a result, we're seeing clients more and more specify one type of software to be used through the entire delivery stage and then in use, which is ridiculous because one software cannot do everything. We force the supply chain into using one application, which will only be adequate for a select number of activities, and you will always need that application to access the information because the language and format is proprietary. So the information ecosystem becomes closed off from anything else, and you're at the mercy of the vendors. The facility will probably outlive the software, and there is no guarantee that the software in the future will be able to open the older data sets. And this is really bad news for our industry. But what if we turn it on its head, flip it around and change the way we currently think? The software should plug in and serve the information, not the other way around, allowing us to access information regardless of the software used. Therefore, we put the information layer first and open it up, so it's freely accessible to anyone who wants to use it, resulting in one information layer which contains all the structures, rules and language to provide consistency across industry. Software changes, it comes and goes, but the information needs to remain intact for many years. This is why software fixes alone cannot solve this interoperability problem. We need a far more sustainable solution. To do this in a consistent way across specify, deliver and check, we need to start with an industry standard, which will give us a framework for managing the information. It's called Industry Foundation Classes, or IFC. The standard of ISO 16739 is actually free, and it's a website. And this is because it cannot be written down as a traditional document. Like many standards, over the years it gets revised and updated. The latest official version is IFC 4.0.2.1. It is managed by Building Smart International and was first released back in 1996. It's a software-neutral open data standard, so it puts the information first above software. IFC can be used across all information management activities in ISO 19650, so all processes use the same consistent information layer throughout, from specifying information requirements, planning information delivery, the delivery itself, and then very importantly checking. It means when two applications can read IFC, it improves interoperability. The receiving platform knows where to look for the data it needs and what the relationships are, so it too can make sense of it. This allows us to automate tasks such as checking, analysing large data sets and carrying out predictions. Humans see buildings and infrastructure as physical things, bricks and mortar. A computer, though, needs to be able to understand what it is in computer language, and that's what IFC is. It's a digital representation of a facility. At its core is an object-based data model, which provides the rules to give everything a unique place and to connect it all up. This is represented by the blue circle. It contains three important parts: entities, attributes, basic properties, and these are all linked via relationships. It's the relationships which make it so powerful. So an instance of a pump is associated with a space and a pump type. The space is located on a building story and may be part of a zone. The story is part of a facility and that sits on a site. The pump will also be part of a system and be connected to pipe fittings. It will have detailed classification assigned to it and also be referenced in documents. It will have basic information like a name, description, ID, and properties like pressure. It might also have risk associated to it. And what does it look like? Well, I'm not even going to attempt to describe this in computer language, so here's a picture. And that's just one pump. Now think of everything else which makes up a facility and how everything interlinks. This is mind-blowingly complex, and it needs to be. These links or relationships are so important, and when we don't recognise these, we miss out on so much more useful information, which can make our projects perform so much better. To communicate the data model, it needs to be given a language and a way of representing it, just like an architect conveys the abstract rules of a building layout using drawings and drafting conventions. For the data model, this language is called a schema, which can be represented graphically. IFC uses several schema. Currently, the principal one is called the Express schema, which is represented by ISO 1030311. And using Express, this is what a tiny part of the IFC data model looks like. This is just like the last two slides in that the entities, which are now in boxes, are connected via lines which create the relationships. And to most, this just looks like gobbledygook, and that's fine because it's a computer that needs to read it, not people, and this operates in the back end of software. This is a building or infrastructure facility turned into pure logic. From this, a computer will know that pump 10 is a circulator pump. It's 300 mil high, is made of a curved surface, and uses 100 watts of energy per hour. In the UK, it's classified as a pressure booster pump. It's connected to the low temperature hot water system 6 via two iron pipe fittings. One is a bend and the other is a junction, and is located in room 100. Room 100 is 2 by 4 metres, located on the third floor of a school called Woodland Primary, which has a gross internal area of 2,000 square metres. Now, can you tell me of anything else in industry which can join all that information up to help a computer understand it? IFC may have a fixed schema behind it to maintain the relationships, but from an information specification point of view, there is flexibility. And it can't predefine everything, so there is an option to add custom properties, and these can be found in the Building Smart Data Dictionary, regional lexicons, or can be bespoke from a client. But it can also link to other external sources, object libraries, documents, and classification. These are considered as part of the overall IFC schema and have relationships like everything else. For example, using the IFC schema, a computer knows that our pump is classified as PR 6553 8612 centrifugal pumps, and that the classification system is called Uniclass 2015. And this is referenced from the 1.18 version of the PR table published in May 2020. So classification actually slots into the schema. The whole IFC schema is huge as it contains most of the digital parts you would ever need during a project. It's not just elements, there are processes, resources, people. We could really go to town. And if you wanted, you could create on-site work schedules from it, to RFIs, to orders. It captures so much for many different purposes, and you wouldn't want to exchange the whole thing, and software wouldn't be able to implement the whole thing. So we need to be able to filter it into mini schemas. This is so we only specify, deliver, and check the information we need for a particular purpose. And this is what the level of information need framework is all about. And for software to implement it so it can be exported and imported. These filters have a name. They're called Model View Definitions, or MVDs, and this one also contains some custom properties. There are several official MVDs developed or being developed by Building Smart International. When we exchange IFC data models, we're in fact exchanging MVD, and MVDs are essentially standardised EIR schemas. The most common MVD exchanged is Coordination View, and this is what it looks like at a schema view. Very roughly speaking, it breaks down like this. Because this doesn't change, I can build rules which will tell me if a door will clash with a light fitting, or to ignore pipes below 20 mm when conducting clash analysis. I can also check the data side, for example, all objects follow the project's naming convention, and that the property flow rate is filled in for all chillers. Since construction is still currently file-based, we exchange IFC MVD data models by creating a file to put the data into. And when you create a file, you need a file format to package the schema up into a file language. For IFC, there are several exchange formats. The main one we exchange is a step file, which is part of ISO 1030321. And because it confusingly has the .ifc file extension, this has caused a big misunderstanding that many think IFC is just a file format and not an entire data model and schema. So when we exchange IFC MVDs, we tend to exchange them using STEP, which is a text-based file format. There is also XML, which is underused. Then there are another 3 in development, where the emphasis is less on exchanging files but exchanging the data. RDF, XML and Turtle are particularly exciting, as these are the formats for linked semantic data, where the relationships are basically on steroids, meaning you can gain so much more useful information from querying the data. IFC is going through a process of modernisation. The Express schema is moving to a UML schema, which is more widely used. The data model is going to be more modularised to make it much more flexible. MVDs will essentially be replaced with information delivery specifications, which is the level of information needs schema for exchange information requirements. And if we go down the route of using model servers, we could start to eliminate paper and perform more advanced queries and analysis, which we're just not doing at the moment to really unlock the data in the models. So a summary, IFC is a data model. It's represented by a schema. It can be exchanged in several file formats and other bits plug into it. It's the information layer of information management in accordance with ISO 19650. Part 7. Construction Operations Building Information Exchange, or COBie. It was developed by Bill East in 2007 following his work with the US Army Corps of Engineers and National Institute of Building Sciences in the US. Quoting Bill, it's a specification of the minimum information set needed to operate, maintain and manage typical buildings. It was published as part of the National BIM Standard United States, or NBIMS for short. Its intention is that it's a defined information exchange over the contractual line between the delivery team and client for import into the client's software systems, like a CAFM system. Once this has happened, it's no longer needed. It's done its job because the data is now in the receiving system. It's not for in-use information exchanges. And if we go back to this scenario and swap the abstract terms for roles, this is what COBie is. The information exchange between client and the delivery team. As mentioned, COBie is an MVD, a mini IFC schema with its own set of rules and conventions, such as what assets are included and what properties. Like all MVDs, it can be customised, and COBie has a small set of properties which aren't predefined within the IFC schema, and additional client ones can be added if required. Zooming in, we can see what attributes and properties are in the overlap and which only exist within COBie. As you can see, a lot of the data is already included in the IFC schema, and the ones which sit outside can still be brought into the overall IFC schema as well. Because COBie is an MVD, it can be delivered using the standard IFC file formats. However, the unique thing about COBie as an MVD is it has a spreadsheet representation. No other MVD has this. And reasons for using the spreadsheet format is because if you think about it, this exchange involves the most people on the project, so it has to cater far and wide. And when it comes to data, spreadsheets are unfortunately still our lowest common denominator. You don't need expensive additional software, which those lower down the supply chain might not be able to afford. Most people will know how to use Excel, if only poorly, and once you move out of the project delivery space, most software, in particular most client software systems, don't accept IFC formats. Therefore, COBie is essentially a simplified version of IFC to be a compromise with where we are now. However, there are challenges in taking something like this and converting it into flat tables, especially when you have data about data. You almost need tables inside tables. This is why you have the tabs at the bottom and in some cases fields duplicated between the tabs. It's basically recreating the IFC schema in a spreadsheet structure, creating its own schema, therefore its own rules. This also means that the location of the data in the spreadsheet changes as it lives in a new place compared to its parent IFC schema. But this doesn't cause an issue because there is a full mapping between the two schemas, so IFC is always maintained and hidden in the background. Think of the IFC schema as being fully digital and the COBie schema a bit more analog because the relationships are more manual. So in a crude sense, the COBie spreadsheet representation just adds another layer of schema on top of IFC, which can fully talk to each other. Everything which can be done in COBie spreadsheet schema can also be done in the IFC-based schema. So that's the basics, but what's BS 1192 Part 4 all about? Through government consultation, the UK took COBie, adopted it and created a British standard for it. We took the NBIM's US COBie and pushed it to do more by adding more potential purposes like health and safety and carbon impacts, applying it to infrastructure and geographical assets, specifying all systems regardless if the individual asset is listed, and specifying additional fields if required. BS 1192 Part 4 is heading towards digitising as much handover information as possible. So in summary, COBie is a mini IFC schema or MVD for the purpose of asset data over the contractual client line, mainly for handover, but throughout delivery if required. It's also not intended for in-use exchanges. It can be exchanged using IFC formats like STEP. However, it can also be exchanged via spreadsheet formats, and to do this it has its own schema which is fully compatible with IFC. COBie is a bit like a simplified entry into the world of schema. Looking at this in more detail in ISO 19650, we have the Project Information Standard. This is where it should be stated that IFC will be used on the project as that consistent information layer. Starting with the purpose, an exchange information requirement is defined. This could be, for example, asset management for a client, or planning construction works, or costing for a contractor. The pieces of unstructured and structured information which are needed to fulfil these purposes are specified across the different layers, and for structured information by the level of information need framework, which breaks the information down into its component parts. For the structured information, the model view definition needs to be stated, which provides the relevant data structure to exchange and deliver the information using software. There is no getting away from this. We're going to have to delve into the world of data models and schemas to help with this. These requirements are handed over or exchanged to those who will deliver the actual information. It's now the turn of the delivery side to work out how they're going to provide it in terms of the who, when and how. A big part of this is looking at the layers of information from a container perspective and the strategy around this, taking into account responsibility, program and software. They will produce unstructured and structured information deliverables, including IFC models in accordance with the correct MBD, which contains only the relevant information as per the EIR. This is then issued back to complete the information exchange, where it is checked against the original requirements. Because the original requirements were defined using IFC and the delivered information is received using IFC, this information is much easier to check automatically. So to end, the information layer, however, will evolve. IFC is starting to go through a process of modernisation, and in the future will make far more use of proper ontologies, linked data, knowledge graphs and the semantic web, where these external data sources can all connect together. And this is the stuff that really excites me. This is where the concepts of the digital twin and smart city come into play. And this is why I believe this information layer very much lays the groundwork for the connected future. So I truly believe we all need to work together to make IFC the best it can be. And when we do get it right, the majority of the industry won't even know that they're using it.